Hello students, welcome again. In the topic 3 of our chapter magnetic effects of electric current, you will learn about the force on a current carrying conductor, okay, which is placed in a magnetic field. Now that conductor could be a straight conductor or it could be in the form of a loop also. Let us see what are the subtopics that you will see here. One is the force on a current carrying conductor which is placed in a magnetic field, and also the Fleming's left hand rule, which will help you to know the direction of the force experienced. Because when you talk about force is a vector quantity, as you know that, so it will have a magnitude and also direction. So the direction of the force experienced by the current carrying conductor when it is placed in an external magnetic field, that can be ascertained with the help of Fleming's left hand rule. Also the construction, of course the principle, construction and working of the moving coil galvanometer. Moving forward, you will understand clearly, every single point will be explained with the help of the diagrammatic representations also. If a current carrying conductor is placed and in an external magnetic field, right, then it is going to experience a force that can be clearly observed by us also. So, and to change the amount of current in the circuit, obviously you can use a rheostat which is going to provide variable resistance, and hence you can change the current in the circuit. Of course, the battery and key arrangement, also battery because to provide the current, and key will help you to on off the circuit also. And you will be using the north and south poles of the magnet. Of course, this north pole will also have a south pole also, but north facing of one magnet and south facing of another magnet, so that you can create a magnetic field. Then if B, capital B is the magnetic field induction between the north and south pole of the magnet, and a conductor of length L carrying a current some I is placed in such a way that the length of the conductor is perpendicular, means 90 degrees to the direction of the magnetic field, okay, the magnetic force experienced by the conductor is given by, that means the magnitude is given by F is equal to BIL. Easy to remember, BIL, where B is the magnetic field induction, I is the current in the conductor, L is the length of that conductor also. Then how should we know the direction of the force experience? For that we will be using the Fleming's left hand rule. So like in the case of the right hand thumb rule, even here also you must use your hand. Say for example, now this is a left hand rule, so you should use your left hand to stretch the fingers in 3 mutually perpendicular directions, the central finger, the forefinger and the thumb. So now how it goes is that you will be aligning your central finger, as you can see, in the direction of the current. So central finger in the direction of the current, the forefinger in the direction of the magnetic field, then the thumb will give you the direction of the force experienced by the conductor. So some students will open their hands only up incompletely, that will not give you complete understanding. Open them properly and then apply the Fleming's left hand rule, you will understand very clearly also. Then the moving coil galvanometer, its basic working principle you will understand, that is a current carrying conducting coil experiences a pair of forces which is also called as couple when it is placed in a magnetic field. Construction, nicely you will be using a moving coil with an iron core kept at its center, placed between the poles of a magnet, and also suspended with a phosphor bronze strip attached with a mirror from the torsion head, and the bottom portion is supported by a spring, the suspension spring. And this particular coil will experience a pair of forces, that is couple, and experience a turning effect, and that turning effect can be measured by this scale and pointer arrangement also. So to note the reading. Then coming to the working, at equilibrium what happens, the coil is being turned due to the interaction with the magnetic field, whereas the spring which is there at the bottom will try to provide the restoring couple. When these two are equated, you get NBIA, which is the deflecting couple, and C theta will be the restoring couple. You get I is equal to C by NBA theta. This C by NBA will be called as a galvanometer constant. Therefore, you get I is equal to K theta. So, by measuring the angle by which the phosphor bronze wire will turn, because you have attached a mirror to that, you will be able to measure the amount of current also. And the same galvanometer, which some modification can be converted into an ammeter to measure current in a circuit. What you will be basically doing, that is for you to find out. At the same time, you will also be knowing clearly how the galvanometer will be transformed into a voltmeter, so that it can be used to measure the potential difference across 2 points in a given circuit. Again, the transformation, how it happens, yes, when you go through the lesson, definitely you will understand. So, happy learning, and thank you.